Good morning, students. In today's lecture, we will discuss the conditions for an equilibrium to be stable, unstable, or neutral. It depends upon the position of matter center, whether the matter center lies above the center of gravity or below the center of gravity or coincides with the center of gravity. So to discuss these conditions, let us consider a body which is floating in a liquid, and suppose it is in the position of equilibrium. Let us take G is the center of gravity of the body where the weight of the body acts. So let us take W is the weight of the body. H is the center of buoyancy in the position of equilibrium. Then by the conditions of equilibrium, the line joining the points G and H is vertical in that position. Means G and H, they lies on the same vertical line. Now suppose we give a rotational displacement to this body such that the mass of the liquid displaced remains unchanged, and let us take H dash with a new center of buoyancy in the displaced position. Now because we have considered that the mass of the liquid displaced remains unchanged, so we can say that the magnitude of force of buoyancy that also remains unchanged, and that will be same as the weight of the body. But because the buoyant force acts vertically upward, so this buoyant force acts vertically upward through the point H dash, where H dash is the new center of buoyancy in the displaced position. Then the point of intersection M of the line HG and the vertical line through H dash is called meta center. Now, what are the forces acting on the floating body in the displaced position? There are two forces. One of the forces, the weight of the body, which we have denoted by W, and it is acting vertically downward through the point G. Second force, that is the force of buoyancy, and that is also W, which is acting vertically upward through H dash. Now, because this is vertically downward force and this is vertically upward force, and these two forces are unlike parallel forces, so they will form a couple. Now, there are three possibilities. Either the meta center M lies above G, or that will lie below G, or that will coincide with G. Let us discuss these three cases one by one. So we consider the first case, when the meta center M lies above G. This we have shown the displaced position of the body. This is the center of gravity of the body where the weight acts vertically downward. H is the old position of center of buoyancy. In the new position, new center of buoyancy, we have denoted by H dash. Through the point H dash, the upward thrust, which we have denoted by W again, that is acting. Now here we can see that this weight and this upward thrust, they are equal and opposite, and these are unlike parallel, so they are forming a couple. Now let us find the moment of this couple. Suppose this angle, the angle GM, suppose this point is N, the angle GMN we have taken as theta. So the moment of the couple, that is given by the magnitude of either force into the arm of the couple, means perpendicular distance of line of action of W from this line. So this distance is given by Gm sine theta. Now Here we have considered M lies above G, means the distance HM, that is greater than the distance HG. HM is greater than HG, so HM minus HG, which is GM, that will be positive. So we can say that in this case the moment of the couple is positive. It means that is anti-clockwise. Anti-clockwise means in this direction. So what will happen? This anti-clockwise moment will tend to bring this line again into the vertical position. It means the body will tend to come back to its original position. And we already discussed yesterday that if a body tends to come back in the original equilibrium position, then such kind of equilibrium is called stable equilibrium. So we have proved that if the matter center lies above the center of gravity, in that case equilibrium is stable. Now let us consider the second case, when the matter center M that lies below the center of gravity. Here we can see that this is the line joining G and H. G is the center of gravity, M matter center, this is the point which is lying below G, and this point H dash, that is the new position of center of buoyancy in the displaced position. This is the vertical through the point H dash, and in this direction that is acting the force of buoyancy, which is W. Weight will act at this point. This is center of gravity of the body. This is weight acting. Here we can see that this weight and this upward thrust, they are again equal and opposite, and they are unlike parallel forces. They are forming a couple. But in this case, because we can see that HM is less than HG, so HM minus HG, that is negative. So in this case, the moment of the couple formed by these two unlike parallel forces, that will be negative. Moment is clockwise, means in this direction, and this moment will tend to push the line GH further away from its original position. And because the body is tending to move away from its position of equilibrium, so we can say that in this case the equilibrium is unstable equilibrium. Now we discuss the third case. In the third case, let us consider the matter center M coincides with the center of gravity of the body. You can see here, this is the displaced position, this is center of gravity, this is the old position of center of buoyancy H, this is the new position of center of buoyancy in the displaced position, which we have denoted by H dash. The buoyant force is acting in the upward direction through this point. G is the center of gravity, weight W, which is acting through the point G vertically downward. Now here M and G coincides. This point is G as well as this point is M, means HM is same as HG. So here we can see that these two forces are equal and opposite and having the same line of actions, means in this case the moment of the couple formed, that is 0. Or we can say that because the point G and H dash, they are lying on the same vertical line, if the center of gravity and the center of buoyancy, they lies on the same vertical line, then the equilibrium is satisfied. So we can say that in this case the body will remain at rest even in the displaced position also. So we can say that the equilibrium is neutral. Thus, combining all the three cases, we can conclude that the equilibrium is stable if HM is greater than HG, means the point matter center M that lies above the center of gravity. The equilibrium is unstable if HM is less than HG, means the matter center lies below the center of gravity G. And the equilibrium is neutral equilibrium if the matter center M coincides with center of gravity of the body. Means HM is same as HG. So these were the conditions for the equilibrium to be stable, unstable or neutral.